everyone. I'm extremely excited to be here. Welcome to the International JavaScript Conference, and welcome to the Node.js program. So my name is Tamar, and today I'm going to talk about Node.js performance, and I'm going to talk about lessons that has been learned by blood and applications that I had to optimize. So I would talk a little bit about myself. Who am I? So I'm a software engineer, I'm a manager, I'm an architect. Right now, I'm working in the most awesome startup called Bit. What we are trying to do is recomponentize the world and help people share code, help developers share code in much more efficient ways. We are dividing packages into small pieces and helping you only be dependent on very small pieces of your code. Awesome product. What I've done in the past, I was the manager of Edgeverve's CTO group. Edgeverve is a company of the size of 10,000 employees, and I was the architect of a product called OE Cloud. I've started a startup of my own, and I was the CTO of this startup. And I was a performance team leader at NCR Corporation. So I'm extremely passionate about Node.js. I have to say, my interest in this platform has started when I founded my startup. And the entire backend was written in Node.js. And since then, I've dived a lot into this platform, and I've done a lot of production code in this platform, but that's where my interest in this platform starts. Node.js is awesome, and it's the best. You can contact me, and that's my email. That's my LinkedIn profile, and you can contact me over there. But let's get back to business and enough talking about myself. So what we're going to talk about today, I'm going to spend really little time in general performance tips that are relevant for every language, every technologies that we have. After that, I'm going to start to talk about Node.js programming patterns to support good performance and how to write your code more efficiently. After that, I am going to talk about the recommended cluster configuration. All of us work in a cluster, and we want to squeeze as much throughput as we can from our configuration. I'm going to talk about promises performance. I guess that most of us work with ES7 and ES6 syntax, and all of us are working with promises and with async await. And at the end, I'm going to talk about JavaScript code optimisations that are codes by the V8 engine and the JIT compiler. So that's what we're going to talk about today. So let's say that my server is running extremely slow, not moving. So the first thing that I have to check are, first of all, make sure that your log level is error. A lot of times I came to a developer and he was crying, this is not moving, what's going on? And it turns out that the log levels were debugged. That's a really common mistake. Make sure that that's happened. The other thing that I would like to suggest is use efficient data structures. That's also kind of a known tip. So throw away all of your linked lists. Usually they're not efficient at all. Go to arrays, go to hash maps, and this would give you much better performance. Consider caching wherever you can, especially if your system is eventually consistent. All right, so consider caching wherever you can. Basically, in the case that you can return to a user a response that will be updated, let's say 20 seconds from now, then consider caching. And the other place that I recommend you to look before starting to diving into your Node code and profiling and banging your head over the wall is the database. First of all, a lot of times one index can just change your life and make everything run really faster. The other thing that I want to talk about is the amount of the results that you are returning. So, most of the times we have entities that they have maybe 20 fields, 10 fields, 15 fields, but sometimes we only need 2 fields. So why selecting everything? Try to consider selecting only what you need. So that's the other tip. And the third tip is just to limit the amount of the results. That also can help you. But let's say that you've done all of that. All of that is done, and still your server is working extremely slow. So now it's the time to get into Node.js and how your code is written. And now is the time to try to understand what we can do better in your Node.js code after doing all of that. So I would like to give you a high-level overview on the Node.js architecture, really in a nutshell, really in high-level overview. But I would like to compare Node to traditional languages like Java, C#, Python, and how they are working. So the traditional approach in most of the languages is an approach called blocking I/O. What is a blocking I/O? And by the way, blocking I/O makes a lot of sense, because if I'm doing an I/O operation, and an I/O operation can be reading from a file, performing a database query, sending an HTTP request and waiting for a response. If I'm doing an I/O operation, then usually I want to do something with that result. So blocking I/O, okay, meaning that my thread is waiting for the results to come back. And after that, my thread is doing something with the results. But while it is waiting, it can't do anything else. It is frozen. All right? How usually developers work in those languages? Usually in those languages, first of all, we're opening a thread for every request. All right? Every request, we're opening a thread. The other thing that we're usually doing is when executing database queries, we are also opening background threads in order not to stack the main threads that is handling those requests. So that is what we're usually doing, and that is how we are usually working. But JavaScript, from its beginning, taken a different approach, and that approach called the non-blocking I/O. That means that once my server, or once my JavaScript code is doing an I/O operation, it can handle a lot of other stuff. Okay, it can do a lot of other stuff in parallel. How is that happened? Well, in a nutshell, we're seeing here the architecture of Node.js. So to give you a high-level explanation, well, I guess that you've all familiar with the pattern or with the manner, with the phrase single-threaded with event loop. To be honest, Node is not exactly single-threaded. What's happening is whenever requests arrive to the server, there is a callback, which is registered in the event loop. And from then, the sequence of callbacks of the event loop is starting, and my event loop is starting to handle the request. Well, in good programming, I/O operations are offloaded to something called the worker pool. The worker pool is a thread pool that is handling I/O operation and handling CPU-intensive operations. It's implemented with libuv library. I would not get into all the details of what's happening in the operation system level. I would just say that when an I/O operation is finished, I am getting a signal, all right? My event loop is getting a signal that I need to handle the results. So that is what's happening here. So right now, let's go into what are the good programming patterns in this environment when we have constant amount of threads to write efficient code, and how we should write our code so it would run faster and we would let's say, utilize the entire power of our environment. So, first of all, let's talk about the biggest mistakes that developers are doing, which is Synchronous API, which I hope that you're familiar with. All right, so what is Synchronous API? And why Synchronous API is bad? So, as we said, we have a small amount of threads, right? We have the event loop thread, we have the worker pool thread, and that's it. All right? Each thread here is extremely critical. So each thread have to do exactly what it has to do. While we're doing synchronous operation, okay, what's happening is that our event loop that should handle requests from a lot of consumers, from a lot of clients, is busy with doing I/O. So that is a very, very big mistake, because if you're doing that, it means that your server is frozen, that instead of handling stuff, it is doing I/O. It is reading from somewhere. It is doing a database query, and you can't handle many more requests. So that is the first type of blocking thread that we have here, and that is the most severe one. Another type of blocking thread, which is also severe, but not as severe as the first one, is doing a long task. If my event loop, my worker pool, I'm offloading a really long I/O operation, a really long database query, then one of the threads in my event loop is blocked. And one of my threads in my worker pool is blocked. And I cannot handle any other things. My server is handling less load. So we have to make sure that the amount for every request, the amount of work for every request that we are doing is small. But I want to talk right now about the case of synchronous I/O, about the blocking the event loop. So here, just a code snippet. We have two APIs, all right? The first one is synchronous, and the second one is asynchronous. Now, I know that you're all working here promises and async await. I put this code snippet with a callback just to make you understand, make the point more clear. In the first example, we are blocking the event loop, okay? I'm reading the file synchronously, and my event loop is blocked and is busy with reading the file. In the second code snippet, well, I'm offloading the operation to my worker pool, and my event loop is ready and able to handle a lot of other stuff. And that is the best situation, and that is the situation that would give us better performance. So, in order to, prove my point, I would like to start with the first demo that we have here in this session. So, I have prepared two servers, which are very, very focused on the point, very, very short. So both of them are based on Express, and both of them are doing really simple operation. Okay, the operation that they're doing is they're getting a password and returning a hash. I hope that you can all see the code. If you can see, I'll try to make it bigger. But both of the servers are exposing one route with a slash, something extremely, extremely simple. And what they're doing is hashing password. If we would look at the hash password function, then here I am using the synchronous API, and I would do a synchronous operation. My second server is doing exactly the same. Also, I'm exposing one route, all right? But here I am using the asynchronous API. I hope that this is clear. Let me just take it one line down. But here I'm using the asynchronous API, and I'm offloading my operation to the worker pool. And that is, the better programming pattern. So right now, what I want to do is to take one of those servers, bombard it with 100 concurrent connections, get throughput and results, and then I want to take up the second server, bombard it with 100 concurrent connections, and compare the throughputs and results. So, you know what? Let's try to do that, and let's start to do that. Actually, I have the first server here up and running already, which I prepared in advance. But I'm going to use a tool called AutoCannon. All right, this tool is very comfortable for working. It gives me metrics out of the box. And here, I'm going to send 100 concurrent connections to my server. So let's start that and see what is going on. Right now, my server is being bombarded. So let's see the results that I'm going to get. Okay, my server is finished. So let's go over those results. What do we have here is the throughput. Throughput is how many requests we have handled per the amount of time that the server was working. So here we have handled 123 requests, the total time. The other two measurements that are very important to pay attention to are the 15th percentile and the 97th percentile. The 50 percentiles means that 50% of the requests were slower than that, time. And the 97% of the requests, meaning that 2.5% of the requests were slower than that time. And usually these are the measurements that we're looking at. So here the 50 percentile is 4.8 seconds, and the 97 percentile is 7.8 seconds. Means that 50% of my requests are slower than 4.8 seconds. Now, if I'm gonna take down this server and take up the second one, and I'm gonna do the same running and compare the results. Let's do everything again, and let's start comparing now the results that we are going to get. 90, 100, okay. So, first of all, I would like to compare the throughput. So before we had 123 requests, right now we've handled totally 428 requests. This is about 4 times better. All right. The other thing that I want to show you is the 15 percentiles. That was 4.8 seconds, but now it's 2.2 seconds. Okay. That is a huge difference. And the last thing that I want to show you is the 97th percentile. If you remember, in the first run, 97% of the requests were slower than 7.8 seconds. Right now, the 97th percentile is down to 2.4 seconds. That is a huge improvement. So, anytime that you have a synchronous operation, just get rid of it. It's extremely important. Just get rid of it and always work with the synchronous API. So that's the first important rule that you have to remember when working with Node. Now, let's go to the second rule, which is called sequential I/O. So what is sequential I/O? I would like to explain. An I/O operation is executed one by one, meaning that I'm executing a database query, waiting until it will go back, and then I'm executing the second one, and waiting until the results would go back. So we're just executing all the operations one by one. Why is that so bad? So, if you remember the Node.js architecture, you have a constant amount of threads in your worker pool. In your worker pool thread, you have a constant amount of threads. While you're not using parallelism, you are not using the entire power of this technology. Okay? It's very important in this technology to run things in parallel. It's extremely important. Okay? So you have to schedule asynchronous tasks to run in parallel all the time to make sure you utilize the entire power of your worker pool. So right now, I want to show you examples in ES5, ES6, and ES7 syntax of how you are creating this specific performance problem. So ES5, I'm giving an honor to the ones here that are writing in ES5, although that I think that most of us are in ES7 right now, Node 8, Node 9, Node 10. So if you remember, we wrote in callbacks here. So here I have 2 collections. I have the user collection and I have the categories collection. Pay attention to one important thing, that the results of the user collection is not needed to run the categories collection. Both of those queries are intact. I can run them in parallel. But I don't know, out of habit, out of something like that, I wrote that one after the other. So that is one way to create serial code or sequential code. And there is the async library that right now it's declining from whoever writing a node because we're all in async await and promises. But async series in the async library is giving us the exact same result. All right? So here we're executing things one by one, and we want to execute them in parallel. The solution that I recommend in order to overcome this problem in ES5 is using the async library, the parallel functionality over there, because no one wants to implement parallel flow themselves. We have it ready. We have it out of the box. So let's use that. So the other, let's go to ES6. In ES6, promises came into our world. And here we're wrapping the categories function with a promise, and we're wrapping the user function with a promise. So this is how you're writing sequential code in ES6. So get users, then on the then callback, I'm registering the user, the categories query, and then on the then I'm returning them. Again, this is not needed. We need to run both of them in parallel. The solution for that is, of course, using promise all. And in promise all, I am using get users and get categories, and we do them in parallel. Now, let's go to async await. And let's go to that specific code sample because it's very important. So, async await syntax have kind of changed our life in ES7 because everything looks so synchronous. Everything is so readable. I mean, it's so much more nice to the eye, and I understand it much more than callbacks. I understand it much more than promises, but it's misleading. Because that looks synchronous. And I think that there is no problem here. I mean, I'm waiting for the users to go back. I'm waiting for the categories to go back. And then I get the results. We have to remember that behind the scenes, everything is asynchronous. Everything is asynchronous. Everything behind the scenes is at the end callbacks. Async await promises are just wrapping. But when we're working with async awaits, it's extremely easy to write this code. I've wrote it multiple times, and then I caught myself just, okay, no, parallel. But that is very, very important to remember. So here we're actually writing asynchronous code, and that is a very common mistake. So how we will overcome that? With our nicely familiar promise all, that would help us perform these in parallel. So when you're working with async await, just make sure that you're paralleling everything. So I would like to show you another small demo, another server that I wrote, which is very focused to this specific problem. And let's look at the code here. What do we have here? I have here two really small entities. Okay, so here is an entity called a person working with Mongoose, only with one field. And it has a, let's say, controller. And this controller is exposing one function, which is what this function is doing is creating the person, right? It's creating the entity. And, the other entity that I've created is an entity called pet. Again, really small, really simple, one string. And here we have another controller which is creating this pet. All right, and here I've implemented two servers. These two servers are using the exact code. Sorry, both of them are working with Express. and Mongoose and exposing one API. So this is a parallel code. What is this doing is with Promisol is saving 8 entities, but it's going to do everything in parallel. All right. So the other server that we have here is exposing one route. Okay. But here we are doing the operation one by one. Okay. Sequential. So these are the two servers that we have here. And I would like to, again, do the same thing. Take one server up. Okay, so I'm going to take one server up, and I'm going to send with autocannon. So right now my configuration would be a little bit different. I'm going to send one concurrent connection at a time because I want to get focus on the latency that we are going to get. So that is a serial code. Let's wait for about 10 seconds for the results that we are going to get. It's going to be finished in 1 minute. So the 15th percentile right now that we got is 3 milliseconds. And the 97th percentile is 5 milliseconds. Okay, so after doing that, let's take that down. And let's run the other one. Okay, and let's do the exact same thing and wait for the results. Okay, so here we've got some improvement. The 15th percentile is 2 milliseconds, and the 97th percentile is 4 milliseconds in against the 6. So I know what you're thinking. You're thinking, okay, I've seen here an improvement of 1-2 milliseconds. But remember, you have a very small server saving 8 entities, and in big system, these things tend to consume. And when you're doing them everywhere, they have a lot of impact. So I just want to say that always look at your code. Try to restructure it. See what you can run in parallel. What I/O operations are intact. What you can run in parallel from your I/O operations. All right? And try to restructure your code according to that. And try to do as much thing in parallel as you can. Okay, so let's continue. And let's talk about how to squeeze more throughput from your cluster configuration. So all of us are working with cluster today. No matter, well, of course, Node.js is one process, single-threaded with event loop. But no matter how fast your CPU is, well, it will not handle the load. It will choke at the end. You have to use multiple CPUs. You have to use multiple processes. So that is the reason why all of us are using cluster, because there is a limitation for one CPU. But which cluster configuration would give us the best performance? So I've made several tests. Well, the first configuration is the Node.js cluster module. The second configuration is using Docker containers and IP tables. And the third configuration is using Docker container and dedicated load balancers such as Nginx or HAProxy. So let's talk about the cluster module. I'm hoping that you're all familiar with it. The Node.js cluster module is a module which is based on the child process module. It enables us to have a master process which is responsible for opening slave or worker processes. It's also responsible for routing the request between the processes and responsible for respawning if something is dead. So that is our cluster module. of Node.js, and that's how it works. And in the first configuration, well, what's happening that all the clients are sending actually the request to the master process. All the workers are responsible for returning the response, and the master is responsible for the load balancing. Well, in the second configuration, we have an HA proxy or an Nginx, and containers are configured to different ports. Nginx is doing the load balancing, and our clients at the end arrive to the Nginx. So that is the third configuration that we have. And in the third configuration that we have the IP tables modules, which the IP table modules is responsible for load balancing. And of course, the containers are listening to different ports, and each container is mapped to a specific CPU. But the IP tables is responsible for the load balancing. So if we're going to see the results of this, well, there is a small difference to the IP tables against the Nginx, but what I want you to pay attention is the difference from Nginx IP table to the cluster model. That's what I want you to pay attention to. Okay, so why there is such a difference? Why the cluster model is handling so less load? Why is that happening? Because the master process is doing several things. The master process is handling requests. The master process is routing the request to the other workers. And the master process is responsible for respawning. And that doesn't come without a price. We want that our Node.js application, if it's mapped to a CPU, we want to use the entire power of the CPU to do what the application has to do. Because no matter how efficient the code that we are going to write, we would not be able to compete with a dedicated load balancer. We would not be able to do that. That is the reason why going to production, I recommend not to go with a cluster model, but have a configuration on your machine of a Docker container, maybe with Kubernetes, but not to use the Node cluster model. If you don't have time and you're looking for a very quick solution in order to utilize the entire performance of your machine, then the cluster model is a good solution. If you don't have time right now, if you're just starting a startup and you don't have time, then the cluster model is a good solution, is a good choice. But if you do have time, or for a long-term solution, I definitely recommend not to use that. So let's go to our next topic, which is the promises performance. So right now in our code, promises and async await are everywhere. All the code that we are writing with promises and we are writing with async await. But think about that behind the scenes, everything is still callbacks. All right? And think about it, that the choice of the promise library that you are choosing, especially when your entire code is working with promises, is significant. All right? So, first of all, I would like to talk about Bluebird promises. Are you familiar with Bluebird promises? Have you heard about it? I assume that you did. Bluebird promises versus native promises of the language. And the second thing that I would like to talk about is what is the overhead of all of this wrapping of promises, of async await on bare callbacks. So, let's go into another really small code sample that I have prepared in advance. I have to admit is very focused on the point. It's very small, but here we have two programs here. Well, they're not doing so much. They're resolving about 1 million promises, and it is very focused on the promise performance themselves. So here we have Bluebird promises. here we're using the Bluebird promises, and we're resolving about 1 million promises. And here we are using the native promises, and we're resolving about 1 million promises. So let's take some time measurements, and let's see. The differences between them. Let's start with Node native. And let's see what we're going to get. 1.8 seconds for resolving 1 million promises. All right, and let's go to Bluebird promises. Okay, we got 1.4 seconds. So here in this machine, I'm working with Node 8.11. So that is the machine that I'm working with. So currently, Bluebird are faster than the native promises. And when your entire code is wrapped with promises, and when your entire code is written with promises, those things tend to count. All right, they're using the memory more efficiently. They are more optimized. So I really suggest that you would use them. I have to admit, I have to tell you something. So one of the members in the Node.js core team told me on Saturday, before I flew here, that they have done some benchmarking and they have succeeded to improve the native promises, but with async await. If you combine native promises with async await, he told me that the benchmarking show that in Node 10 right now native are faster. But since it was on Saturday, I didn't have time to run serious benchmarking. But I have to tell you that also in Node 9, in serious benchmarking, Bluebird are still better. Are still better performance-wise. So regarding that comment, I would go back home, run serious benchmarking on a different machine, and I would tell you, I would publish the results, maybe in my Twitter account. But as far as I know, even in Node 10, I mean, these improvements came only right now. Even in Node 10, Bluebird are still faster than the native promises. So that is the first thing. The other thing that I want to talk about is callbacks vs promises vs async await. So async await and promises are wrappings. The original code was written in callbacks. So here, if anyone wants, he can contact me offline. I will direct him to the full benchmarking done here. But this is a specific benchmarking done for Node 8.4 and comparing performance of a production application, working with callbacks, working with Bluebird promises, working with async await plus Bluebird, working with native promises plus async await. So let's go over it. You see that callbacks are 160 milliseconds. And then you see that Bluebird promises add about multiply the time. And then you see that async await plus Bluebird give us multiply by 5 the time. It was 160 milliseconds. Suddenly it's more than 500 milliseconds. So my point is, first of all, I recommend to write everything in the newest syntax. I recommend to write everything with async await. All the new APIs are coming with promises. And the other thing that I want to tell you, if you want to handle more throughput, you can overcome this problem by taking up more instances in your cluster. But if you are in a situation, I've been to those situations when I have a microservice which is complex and doing a lot of logic, and needs to have a response time of 2 milliseconds, on that cases, when you want to optimize the response time, consider not using promises. Okay? If you're only talking about the throughput, that might be solvable by adding more instances, by adding more containers. But if you're talking about fight for every millisecond, having a microservice that needs to work in, I don't know, super fast and fighting with a response time, then just drop the promises. But in most of the cases, you don't have to do that. You just have to remember that promises adds an overhead for you. So that's what you have to remember. So now, after talking about all of that, let's go into the last part of our session, which is JavaScript code optimizations. And here I will talk a little bit about optimizations that are provided by the JIT compiler and by the V8 engine. So, first of all, let's talk about loops for vs for each. So one nicely thing that for each is giving you is not iterating over empty elements in your array. So if all of your array is full, then it doesn't make a difference. But if you have an array which has some empty elements, then it can make a difference, and it is important. So I would like to show you a really small code snippet that, again, I've prepared in advance. It's very simple. We have an array of the size of 10,000. All right, so we have a value only in index 0 and in index 434. Okay, so here are the only places that we have a value, and I would do 2 loops, one of them using for, one of them using for each. And let's see what we're gonna get here. I would run this. Okay. You've seen what happened here. I'm4 is printed multiple times, and I'm4 each is printed only 2 times. So that is one nice optimization that you can do. So that is the first thing that I would like to talk about. The second thing that I would like to talk about is putting common code in functions. All right? So, by the way, copy-paste is a really bad practice. Don't use copy-paste. But if you are using Node, then V8 and the JIT compiler are giving you a bonus for not doing copy-paste. There is a binary which is attached to your function or your object. All right? That when this binary is connected, then there are optimizations that the V8 compiler, that the V8 engine is doing. The JIT compiler is storing this binary, and the V8 engine is doing some optimizations and helping your code run faster. Another thing which is related to copy-paste is creating a class for your objects. Here, the same thing happened. There is a binary. If you're creating a class, there is a binary created by the JIT compiler and is attached to each object that you have and causing the V8 engine to work much faster. And that is also super cool. So, I'd like to show you that in action. Again, just a really small code snippet. Look what's happening here. I have a class with several parameters, and let's try to generate about 1 million objects, for my opinion, when in the first one I would not use a class, and in the second one I would use a class. And let's see, what are the differences here? Okay, so look at the results in the bottom of the screen. When I'm using a class and when I'm not using a class, the time is multiplies. Well, we're talking about 4 milliseconds versus 2 milliseconds here, but think about a huge microservice that needs to handle lots of objects. So if you're using classes, then you're optimizing, and your entire program would work much faster, as you can see here in this very isolated focus demo, about twice as faster as it would work without it. So let's talk about the other rule of thumb. Avoid using delete. I hope that you're familiar with the delete reserved word. Again, when you're using delete, the JIT compiler, all right, is invalidating the contact between the binary, which is connected to your object, and it treats the object as not related to the class. That's, in a nutshell, in a high level, what's happening over there. So, always when you want to delete a property or remove the value from a property, work with undefined. Okay, it's much, much better. And you would get better performance. And the other thing that I want to tell you is avoid using dynamic properties. So when you're using dynamic properties, then the same thing happened. The JIT compiler disconnects the connection between the object and the binary that it is produced, and you're losing the optimization of the V8 engine. So that is another important thing that you have to remember in your mind. The last thing in this section that I would like to treat are arrays. So if we're talking about traditional languages, strongly typed languages, then arrays are allocating continuous blocks of memories. So arrays are allocating continuous blocks of memories, but in JavaScript, what's happened in JavaScript is that arrays were more like, let's say, a linked list. I have a pointer from here to the next cell, to the next cell. Why is that happening? Because we're not strongly typed, and we don't know in advance how much memory we need to allocate in order for the memory to be continuous. Well, in ES6, we were introduced to the typed arrays. All right, and also right now we have TypeScript, so we can define types for arrays, all right, or for our code. And when we're using, let's say, typed arrays, or when we're using TypeScript and defining a type for our array, what we would get is continuous memory allocation, all right, which is much more efficient and much more faster than the old arrays that we were used to work with. And in those cases, insertion and reading would become much faster. So let me show you that happening in action. Okay, so let's look at that code sample. I have here an array, and the first array is a typed array for integer, and I'm looping over this array. Again, it's extremely big, and I'm giving an integer value here for every iteration that I have. The other array that I have, just pay attention here, I have made a small trick. I just put an object in the first place, and in that way I had confused the JIT compiler, and the JIT compiler doesn't know how to treat that. And what would happen here, I'm again iterating on this array, and I'm assigning integer values. So let us run this specific code snippet and see the result. What happened? Well, maybe I don't. Yeah, maybe. What? Oh. Yeah, that's explained it. My mistake. Oh, no. Yeah, you're right. I'm in the wrong folder. Sorry. Oh my God. Yeah. So you have to excuse me for that. I hope that would go down in the editing. Yeah. Okay. Okay, good. Thank you very much for helping me out. Too many folders, too many demos, but let's look at the results here. So in the typed array, insertions is 25 milliseconds. In the heterogeneous array, it is 723 milliseconds. Look at the difference, and that is because we didn't allocate continuous memory. And thank you very much for helping me to overcome the mistake. So last thing, the really last thing that I want to talk about in this session is low priority jobs. So most of us in our servers has to write low priority jobs. I would give several examples such as retention policy. If I want to transfer data from my main storage to my secondary storage. And another thing that I would like to give you an example to is, for example, right now I'm writing a microservice which is stateful. And I have, let's say, a recovery or a watchdog that is trying to check what is the state of my microservice and trying to recover it. Node.js is not the best. Is not the best platform. Is not a good platform to do low priority jobs. That's I want you to remember, because we cannot open threads, and we are adding an overhead to our program. If you have to do it, then write a new microservice. Move it to a different process. Don't do it in the same process. But if you're like, I don't know, in a situation when the sword is on your neck, all right, and you have to do it in the same process, then make sure that the microservice, make sure that the background process is as light as you can. But really, just take it out to a different process. That's the best thing to do. So I can talk a lot about this subject and a lot of optimization that can be done in Node, but that's it for that session. Anyone has any questions? No? All right. So thank you very much for listening. You can contact me here, and feel free to contact me in my Gmail or in my LinkedIn. And that's it. Have a nice day.